The next topic is switching regulators, also known as SMPS, switched mode power supply. The regulators discussed so far, they are of linear voltage regulator and they have certain limitations. Input step-down transformer is bulky and it is the most expensive component in the regulator. Large values of filter capacitors are required. Efficiency is usually very low. The input voltage must be greater than the output voltage. In switched mode regulator, pass transistor is used as a controlled switch operated at either cutoff or saturated state. Hence, the power transmitted across the pass device is in discrete pulses rather than as a steady current flow. Since the pass device is operated as a low impedance switch, greater efficiency is achieved in the range 70 to 90%. Switched mode regulators rely on pulse width modulation to control the average value of output voltage. The average value of a repetitive pulse waveform depends on the area under the waveform. If the duty cycle is varied as shown, average value of the voltage changes proportionately. So this is the complete functional diagram of a switched mode power supply or switching regulator or SMPS. Bridge rectifier and capacitor filters are connected directly to the AC line to give unregulated DC input. A thermistor RT limits the high initial capacitor charge current. The reference regulator is a series pass regulator. Its output is a regulated reference voltage V reference. Transistors Q1 and Q2 are alternatively switched off and on at 20 kHz. These transistors drive the primary of the main transformer. The secondary is center tapped and full wave rectification by diodes D1 and D2. This unidirectional square wave is next filtered through a two-stage LC filter to produce output voltage. The regulation of V0 is achieved by the feedback circuit consisting of a pulse width modulator and steering logic circuit. So these are all the various waveforms showing the operation of a switched mode power supply or SMPS. The output voltage V0 is sampled by a R1 R2 divider and a fraction R1 divided by R1 plus R2 is compared with a fixed reference voltage V reference in comparator 1. The output of this is called V control. V control is applied to the negative input terminal of comparator 2 and triangular waveform of frequency is applied to the positive input terminal. The comparator 2 functions as a pulse width modulator and its output is a square wave VA. The duty cycle of the square wave is T1 divided by T1 plus T2 and varies with V control, which in turn varies with the variation of V0. The output VA drives a steering logic circuit. It consists of a 40 kilohertz oscillator cascaded with the flip-flop to produce two complementary outputs, VQ and VQ bar. The output VA1 and VA2 of AND gates A1 and A2 are applied at the base of transistor Q1 and Q2. Waveform at the input of the transformer will be a square wave, a switch with low losses, and a filter with high quality factor. The conversion efficiency can easily exceed 90%. So this is to justify why SMPS has better efficiency than linear regulated power supply. Very high frequency signals about 40 kHz are being applied. Transistor Q1 or Q2 is on for very small duration and consumes negligibly small power. High operating frequency used allows the use of smaller transformers, capacitors, and inductors. This allows a decrease in size and cost.